All right, so we are on radicals and rational exponents now. Learning goals for this lesson. I can rewrite expressions using radical exponents, rewrite expressions in radical form, identify and explain equality when given two expressions in different forms, and show the steps to simplifying a radical expression. All right, so first, radical form and rational exponents. If you're given an expression and it's in radical form, so it has a radical or a radicand, that's this thing right here. Okay, that's called a radicand. You might hear it called a radical, just so you know what people are talking about. And let's say we need to write it as a rational exponent. We do the following. So if we have a setup like this n, and we need to write it as a rational exponent, that n goes underneath the m, get rid of the radical, and we write that as a fraction. All right, so it would be a to the m over n. Something to keep in mind, a has to be positive if n is even. If it's not, then don't touch it, okay? Because that is not a real number anymore. So just something to keep in mind there. So for example, if we have the square root of 13 raised to the 7th power, we would rewrite that as 13 to the 7 over 2. And you might be wondering, well, where did this come from? Just like if we have x, it's the same as 1x. If we have a radical, it's the same as, so let's say we have the square root of a, it's the same thing as saying a to the 1/2. It's like there's a 2 here that we just don't need to write. The only time we write it is if there's a number bigger than 2. Okay, so that's what that's all about. Keep that in mind. Make sure you know that. So for the first example, rewrite the following expression in exponential form. Well, this one's fairly simple. We've got our 7. We have this 3 right on the radical there, and we're going to just scoot it out to here and get rid of that radical. Now, the thing to keep in mind here is that you need to do one very important thing. So notice how we have 5a underneath the radicand. If we have a variable with a coefficient that is under it, you treat it as one term. So don't forget to put parentheses around the entire term. So notice I have parentheses around the 5a. What this does is this applies this exponent of 7 over 3 to both of these. This is not the same as this. In this case, the only thing that has the exponent is the a. So this and this, not the same. Just keep that in mind. Another very important thing that's easy to go wrong with, especially if you're using a calculator. Okay, radical form, rational exponents. When you're given an expression as a rational exponent and need to rewrite it in radical form, you just reverse the process we just did. So now if we have like a to the m over n, this n will simply go out in front, and we will add a radicand this time to make it look like this. The other way you can write this is that they mean the same thing. So one is not more correct than the other. The only thing I would say is if there's a coefficient here, make sure that you put the parentheses around the a and the coefficient, or just write it like this. For example, if you have 6 to the 5/3 power, we would just rewrite it like that because that 3 goes out in front. Add that, bam, done. Okay, we need to rewrite the following expression in radical form. Again, just fairly simple one. We're going to take that 3 and scoot it out in front. Remember that the denominator of the exponent goes outside the radicand, and the numerator can go underneath with the term or outside the parentheses. So I can write it either of those ways. Either way will be correct. All right. Now, rewrite the following expression in radical form. We have something that's a little bit trickier. All right, so we're going to make sure that we remember how to multiply rational exponents from the last lesson that we did. So we've got our 12, we have our 3, and so we have this. We don't have any exponents on these, so we will just multiply those. And then we have 1 base, 2 bases, and then 1, 2 powers. So all we're going to do is add those together. Remember your rule about having to have common denominators in order to add those, because they're fractions. So I have 36 times x, and then notice I have converted that 3 because it's 3 over 1. If we have or need a denominator of 8, we multiply the top and the bottom by 8, which gives us a 24 over 8, which will give us 36x to the 31 over 8, but it needs to be written in radical form. Okay? So, the other thing we need to keep in mind here is that notice there was not parentheses around the whole thing. Okay, that x was the only thing that had this exponent here. So that's why that 36 is outside of it. It is not underneath with the exponent. So just please bear that in mind. All right, fill in the box with the correct symbol, either equals or does not equal, and briefly explain your choice. Well, we would need to get these into the exact same form in order to better determine that. They do not equal each other because the expression on the right ignores the 2 in the numerator of the rational exponent in the expression on the left. So yes, they brought that 5 out in front and had the radical, but we still had this 2, which got ignored. So if you were to pardon my grammar, if you were to write the left expression in radical form, this would be the correct way of doing it, and then when we simplified that, it would become this. So that's why they are not equal. Okay, explain why both sides are equivalent when written in exponential form. Okay, we have an even number outside the radical, so we are given that x has to be greater than or equal to 0, so that's important. And then what you're going to want to do is you're going to want to probably write this as a rational exponent first and then rewrite it in radical form when everything is simplified. So I take that, and remember what I said, that this is just going to kind of scoot out here, and since that squared is just with the x and not the entire thing, it's going to stay with just the x. Okay, 81 can be rewritten as 3 to the 4th. So one way to figure that out is we know that 81 can be simplified to 9 times 9, which can be simplified to 3 times 3, and since there's 2 9s, we have 4 of them. So we can rewrite this as 3 to the 4th. It makes it a lot easier if you're able to do that. So we have 3 to the 4th to the 1/4 power, because that 1/4 is outside of the parentheses, and everything inside then gets raised to the 1/4 power. And then x squared to the 1/4 power. When you do this, that 1/4 times the 4, so we have 1 base, 2 powers, we multiply. Those will cancel out because 4 times 1/4 is just 1, which is why I have this there. X squared to the 1/4 power, so 1 base, 2 powers, which means that we multiply them. 2 times 1/4 is 3 times x to the 2/4 power, which is the same as 3x to the 1/2 power. If we take the right side and rewrite it, we get the exact same thing. So we've now shown that they are in fact equivalent. So when written in exponential form, both expressions simplify to 3x to the 1/2 power. And that's it. I know it's a lot to take in. This is one of those things that you have to practice with it and make sure that your answers are right so that you understand it. So any kind of questions you have, you need to just keep asking the questions until you understand it. So that's it for today, though. Make sure you understand this before moving on to the next lesson. All right.